We have a few more things I want to do with integrals before we move on to the new integral techniques we're going to learn. This isn't exactly, we didn't do anything quite like these in AB, but it's really just putting together some things you learned before in Algebra 2, way back when, with what we know in calculus. If you notice, we have powers that are equal on the top and the bottom. I heard one math teacher call these Dolly Parton problems because they tend to be top heavy. But if you see powers that are the same on the top and the bottom, or if a power is bigger on top, what you'll often have to do is long division. So right now there's no normal method that we can do that is going to let us do it. We can't use inverse trig or u sub to make this work out. So we're going to have to use long division first. Now, some of you may be thinking, oh, I like synthetic division a lot better. The problem with synthetic division is it only works if you have a linear term on the bottom. And we don't have that here. Regular long division will work no matter what. You can always use long division. So let me show you and remind you how to do long division. We're going to do two of these. So let's say we have x squared plus 1 going into x squared plus x plus 1. Okay, I don't know if your teacher drilled this into you like mine did back in 4th grade, but when you're doing long division even with just numbers, the process is divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. We had to say that over and over in class. Felt like a little cult. But anyway, x squared divided by x squared. You just focus on the first things first. So I do x squared divided by x squared. That's my division. And x squared goes into x squared one time. Now I multiply. 1 times x squared, 1 times 1. Now I subtract. It's a good idea to put the parentheses around to make sure you're subtracting the whole thing. X squared minus x squared is 0. X minus nothing is x. 1 minus 1 is 0. Now x squared will not go into x. It's too big. So that turns out to be our remainder. So we end up with this. Because you take your remainder and you put it over top of whatever you're dividing by. So this equation up here is actually equal to 1 plus x over x squared plus 1. And now we can do that because we can treat those as two separate things. The antiderivative of 1 is just x. And if you look at part 2 of the video, we've already done this integral right here. Just with u sub, u would be x squared plus 1, du would be 2x. So we divide both sides by 2. And we end up with 1/2 du over u. I know I'm not writing that all the way, but you've seen that exact one earlier, so I don't want to waste the time on you. So I have 1/2 natural log of x squared plus 1 plus c. So if you notice, the calculus part really isn't any more difficult. You still end up just doing regular rules or u sub, but you've got to do some funky algebra to get there. In this case, long division. And again, the key to know you may need to use long division is if the powers are the same on the top and the bottom, or if it's bigger on top. So I'm going to show you one more like this. And this one looks pretty fun, right? X squared plus 3 divided by x cubed minus 3x squared plus 4x minus 9. So x squared goes into x cubed x times. It helps you just actually divide. X cubed divided by x squared, that cancels out all but 1x. X times x squared is x cubed. X times 3 is 3x. So notice I always put these, I line them up. So I put the x with the x's, the x squared with the x squared, and so on. So now I'll subtract. X cubed minus x cubed is 0. Negative 3x squared minus 0 is negative 3x squared. 4x minus 3x is x. And then negative 9 we just bring down. So divide, multiply, subtract, bring down. Now x squared will go into negative 3x squared negative 3 times. Then we get, that was the division. Now we multiply. Negative 3 times x squared. Negative 3 times 3. So now if we subtract, negative 3x squared minus negative 3x squared is 0. X minus 0 is x. Negative 9 minus negative 9 is 0. So our answer then is x minus 3 plus our remainder x over x squared plus 3. So now, if we separate this into two integrals, the left one's going to be really simple. In the one on the right, we can use substitution. U equals x squared plus 3, du equals 2x. So we get 1/2 integral of du over u. So if we back up, this one right here turns into 1/2 x squared minus 3x. This becomes 1/2 natural log of absolute value of x squared plus 3 plus c. So that's how you do long division with your integrals.